Yellowstone is known as one of the most extraordinary geological regions on Earth. Beneath its surface lies a massive magma system that has produced catastrophic eruptions in the past. However, Yellowstone also holds another, equally fascinating history. For hundreds of thousands of years, this region was repeatedly covered by massive glaciers as the Earth entered ice ages. This raises a question that continues to be researched by scientists. Are climate change and melting glaciers related to volcanic activity in Yellowstone? Yellowstone is a unique place where two very different natural forces meet. On the one hand, the region boasts a geologically active supervolcano system. On the other hand, the region has been repeatedly covered by thick layers of ice during glacial periods. This is because both events occurred at the same time in Yellowstone's history. Scientists are trying to determine whether there is a connection between the two or whether it is simply a coincidence. To answer this question, researchers need highly accurate dating methods to pinpoint the exact dates of volcanic eruptions and glacial periods. Using argon isotope dating of volcanic ash deposits, scientists estimate that the Yellowstone caldera formed approximately 631,300 years ago. Since the massive eruption that formed the caldera, Yellowstone has experienced at least 28 rhyolite eruptions within the caldera. For about the past 1 million years, Earth has experienced ice age cycles that repeat every 100,000 years or so, following changes in Earth's orbit and axial tilt, known as Milankovitch cycles. Through cosmogenic isotope dating of boulders left behind by glaciers, scientists have identified two major glacial periods in Yellowstone. The first is known as the Bull Lake Glaciation, which lasted approximately 150,000 to 140,000 years ago. The second is the Pinedale Glaciation, which is much younger, lasting approximately 22,000 to 14,000 years ago, when a layer of ice nearly a kilometer thick covered parts of Yellowstone. No evidence of older glaciations has been found, because lava flows and thick deposits of volcanic ash likely buried them. When scientists compared the ages of the lava flows with the ages of the glacial deposits, they found that they did not exactly coincide. This means that, to date, there is no strong evidence that an ice age directly triggered the Yellowstone volcanic eruptions. Yellowstone geologist Robert L. Christensen once proposed that one of Yellowstone's lava flows may have once flowed near an existing ice sheet. However, modern dating indicates that the lava flow is approximately 109,900 plus or minus 2,100 years old, much younger than the end of the Bull Lake Glaciation. This age discrepancy has led scientists to suspect that there is still a part of Yellowstone's geological history that is not fully understood. There may be older lava flows, or perhaps a local ice sheet still existed at the time of the eruption. Fieldwork continues to unravel this mystery. Although no direct link to volcanic eruptions has been found, scientists have discovered something very interesting. Approximately 14,000 years ago, as the Pinedale ice sheet began to melt and disappear from Yellowstone, several large hydrothermal explosions occurred in locations such as Mary Bay, Rush Lake, and Pocket Basin. Geologically, this is considered very close in time. However, scientists remain cautious. They caution that correlation does not necessarily imply causation. Just because two events occurred almost simultaneously does not mean one caused the other. As the nearly 1 kilometer thick ice sheet melted, the enormous pressure that had been pressing on Yellowstone's surface for thousands of years was released. As a result, the hot underground water became more likely to boil. The resulting steam increased the pressure beneath the surface until it eventually cracked the rock, triggering powerful hydrothermal explosions. These events differ from volcanic eruptions in that they do not involve the release of large amounts of magma, but rather explosions driven by the pressure of hot water and steam. To date, there is no scientific evidence that melting glaciers can directly trigger an eruption of the Yellowstone supervolcano. However, research suggests that the loss of the ice sheet likely played a role in increasing hydrothermal activity and triggering large-scale steam explosions. Yellowstone still holds many secrets beneath its surface, and those mysteries continue to be the focus of scientific research today.